the example 11.9 in probability distribution. Especially in this sum, we are going to find the probability mass function from cumulative distribution function. So far we have to find the cumulative distribution function using the probability mass function, but conversely here we are going to see what it means. It is nothing but, suppose x is a discrete random variables taking the values x1, x2 up to xn, that x values like x1, x2, x3, ditto, ditto, and so on, it is going on. Its value, suppose if it is like, okay, so f of xi is a distribution function, cumulative distribution function. That formula is p of x is equal to x is equal to f of xi minus f of xi minus 1. It is nothing but, suppose if you have to find the probability mass function from cumulative distribution function, we have to subtract this function from this function. First function from second function. Here I is equal to 1, 2, 3 and so on. Okay, if x be a discrete random variable and it takes values on x1, x2, x3 and so on. Suppose that values, it will be x1 less than, x2 less than, x3 and so on. So we can easily derive the probability mass function if it is p of x is equal to x is equal to, this is the formula, f of xi minus f of xi minus 1. Here I is equal to 1, 2, 3 like. Okay. See, it is nothing but, suppose this is known as the f of xi, means we have to subtract this first function from the second function. Okay. See, from the given datas, first we have to know the given function x be a discrete random variable, and easily we can write the random values from these datas. What are all the random values? See here, which one is known as the random values? In previous sums we have seen one dice throws 2 times means the total score is equal to, we have to find, we add that 2 scores. Like here, see here, this is the values, -2, -1, 0, 1. These 4 values are known as the random values. Okay, by using random values we are writing this limits. Conversely or inversely, here we are going to write that random values by using these limits. In previous sums we have found the values first, then we have write the limits. Here reversely we are going to do. See here, find the probability mass function f of x of the discrete random variable x whose cumulative distribution function f of x is given. Okay, we have to find first part p of x less than 0, second one p of x greater than or equal to -1. Okay, see here, solution. Let x be the random variable. From the given table, it takes on the values. What are all they? -2, -1, 0 and 1. First thing we found, what we found? Random values. Second step, definition we know. What is that? We have to find probability mass function, isn't it? So probability mass function means f of x is equal to, already we have seen f of x is equal to p of x is equal to x. This P is known as the probability function. This F is known as the frequency function. Isn't it? Already we have seen. Therefore, the just you draw one number line and plot the values that are discrete random values. See 0, 1, 2, minus 1, minus 2. See here we got the random values from minus 2 to 1. From left hand side. Left hand side means in number line, if you are taking left hand side minus 2. So we have to I told x1 less than x2 less than x3 like it should be. That time only we can use this formula P of x is equal to x, f of xi minus f of xi minus 1. But here therefore we are taking left hand side means what is that? F of minus 2. The left hand limit. Left hand limit we have to take now minus 2 f of x at minus 2 is equal to x is equal to minus 2 is we have to write like f of minus 2 minus 2. Okay, then next step we have to use that similarly for other terms we have to find the points. First we have to find f of minus 2. See what I told, f of x is equal to p of x is equal to x. First f of minus 2 we have to find. What is that formula? F of minus 2 means this is the bigger number comparing to this, isn't it? So we have to subtract f of minus 2 p of x is equal to minus 2. For this p of x, what formula? F of xi minus f of xi minus 1. But we have to subtract this. Previously one more limit is there means we have to subtract this limit from this, isn't it? So f of minus 2, this is f of 2 minus 2 bar. Okay, we have to subtract this limit from this. F of minus 2 what we have? 0.25. See minus 2 0.25, minus 2 0.25, minus 0 is equal to 0.25. Similarly we have to find other jumps. Here that value is jumping, isn't it? See, we have to find the value distribution function for minus 2. We have that formula f of x is equal to p of x is equal to x. This f of x is known as the frequency. This is known as the probability function, then for this probability we have another one formula. What is that? Means f of xi minus f of xi minus 1. When we can use this formula, if x is a discrete random variable and it takes values on x1, x2, x3 and so on, if we are describing that f of xi is a distribution function, cumulative distribution function, so we can able to write p of x is equal to x is equal to f of xi minus f of xi minus 1. By using this formula, we have to find the jump of first limit, left hand side, minus 2 if you are going to take, we have to subtract this limit from this. But this we don't know that value. For this we are getting 0. For these values it having some value function, isn't it? So here 0. Then f of minus 1. F of minus 1 means p of x is equal to minus 1. See, p of minus 1 means p of minus 1 minus p, f of, formula is f na, f of minus 1 minus 2. Where we are getting minus 1 value? See 0.60. We have to write 0.60 minus 0.25. What we are getting? 0.35. It is jumping here. Then like same f of 0, f of 1 we have to find. F of 0. P of x is equal to 0. 0 mean what it will come? P of x is equal to minus 1. X P of minus 1 minus 0, 0 first it will come, second only minus 1. What is 0? 0 means 0.90 minus 0.60. So 0.30 here it is jumping. Next one f of 1. F of 1 means P of x is equal to 1. You just draw this number line minus 2, minus 1, 0, 1, 2. See f of x1 we have to find means P of x is equal to minus 1 means f of 1 minus f of 0. F of 1 value what is that? F of 1 value is 1 minus f of 0, 0.90. So 0.10. We have to show these values, how it is jumping. We have to show it on the graph. See here, 0, minus 1, minus 2, 1, 2, 3. For first value what we are getting? Minus 2, 0.25. Minus 2, 0.25 means approximately here it will come. Then f of minus 1, 0.35. 0.35, 0.525, okay, like we will 0.25, 0.50, 0.75, 1, okay. See here it will come. 35 means we have to add with 0.25, 0.60 it will come. This it will come here, okay. Then third value what is that? 0.60, 0.09. 0.09 means here it will come. Here it will come. Then 1. We have to draw like this. See, for minus 2, 0.05. How much it is jumping? 0.35 it is jumping. So this jumping they are telling. Here 0.25, here 0.35, here this jumping it takes 0.30, here 0.01. Okay, they have given these values. See here 0.25, it jumps to 0.60, in between 0.35, it takes that measurement, the thing we have find and we have mentioned on this graph. Then first option what they are asking, P of x less than 0. P of x less than 0. It is nothing but minus infinity to less than 0 means minus 1 it will come. P of x is equal to x. Okay. In that what we have, just to see that number line 0 up to 0 they gave us. So minus 1, minus infinity to minus 1. So minus infinity to minus 2, minus 2 to minus 1. P of x is equal to x less than minus 2 we can write. X less than minus 2 means it means minus 3, it means minus 3 plus p of x is equal to minus 2 plus p of less than 0 na, p of x is equal to minus 1. Up to this we have to find. So, minus infinity to less than 2, minus 2, then minus 1. For this value 0 we know, p of x minus 2 is equal to what we have, 0.25, less than 2, correct, 0.35, see what it will come, 0.60. See, less than 0 means, less than 0 we got 0.60, that answer is correct. Second option, x greater than or equal to minus 1. Greater than or equal to minus 1 means it will come 0.90, it also including, so that value little bit it will be changed, we will find, see here minus 1 to infinity, okay, p of x is equal to x, but what we have, directly we can write p of x greater than or equal to, they are asking now, so we have to add this minus 1 plus 0 plus 1. What is its value? 0.35. Minus 1 means what is that? It is jumping na, so 0.35 plus here 0.30 plus that jumping values we have to write here. So totally 0.75. This is the answer. Here more greater than or equal to 1 they are asking, so we have to find the jumpings. Okay. Thank you.